Good morning, everybody. I apologize that this video is taking me longer than I thought. I've had some issues with internet and things not backing up and things not syncing and all of that lovely stuff. So I am going to go through this in parts, and I'm going to be kind of hopping from one section to the next section and so on and so forth. You'll see my time down in the corner down here change a lot because I'm going to do section by section. I'm going to try to do them in between my Zoom meetings. So bear with me. I apologize for what's going on. Okay, so we're going to start with our first section sample problem. This one has a redox reaction that's given. It also says to indicate which substances are oxidized and which are reduced. And then you want to indicate the oxidizing reagent and the reducing agent. So these are going to be definitions from the chapter that we will get to towards the end. But the first thing we need to do is actually do oxidation numbers to start us off. So first things first, ones we know are always true. Our oxygen is a -2. So we know that that oxygen's a -2. We also know this oxygen's going to be a -2. We know that it's not going to change charge from left to right. That's kind of a big thing we need to know. And so on. So the next thing we're going to do is we're going to see that according to our rules, so you want to have your rules with you whenever you're doing these problems. The first rule says that if it's in its elemental form, so by itself and in the solid state, then its oxidation number is 0. So this one is going to have a 0. I'm going to just write -2 for all the oxygens, because if I write O, then O and 0 looks the same. The next thing that we want to look at is the nickel on the left side. Since it's attached to 2 of the negatively 2 charged oxygens, that means nickel is going to be a +4. Again, this is because each one of these is a -2, nickel is +4. That makes it neutral. All right, then on the right side of the equation, we want to look at cadmium and nickel, because we know oxygen is not going to change, and we know hydrogen doesn't really come into play here. Hydrogen is a +1 on the left side. It's going to be a +1 on the right side. So we know that OH has a -1 charge, so that means since there's 2 of them, that cadmium has become a +2, and we know that nickel on the right side also has become a +2 because of the O2 changing. All right, so now I'm going to clean this up. I'm going to get rid of the oxygen charge. We don't really care about the oxygen charge. We do care about cadmium being a +2 on this side. We do care about nickel being a +2 on this side as well. All right, so now what we're going to look at is how each element that we're seeing change charge changes from left to right. So for cadmium, it went from a 0 charge to a +2, which means in order to become more positive, this one lost electrons. In order to become less positive, this one gained electrons. And now using your mnemonic, we know oxidation is loss, and we know reduction is gain. Okay, so now we know that the thing that was oxidized is the thing that lost electrons. So cadmium was oxidized, and nickel was reduced. And that is our indicating which is oxidized and which are reduced. So we've done that first part. Next thing says to identify the oxidizing agent and the reducing agent. So remember that it's whatever the opposite is. So for instance, cadmium, since it was oxidized, it was the reducing agent. And nickel, since it was reduced, it is the oxidizing agent. And technically, it's the nickel O2 is the whole thing in this case. Okay. All right, so that was the first one. Next one that we're going to cover is on completing and balancing the method of half reactions. So what I'm going to do right now is I'm going to go through the steps. I just want to write the steps out, and then I'm going to pause and come back to this. So the first step is to determine all oxidation numbers. That's the first thing we're going to do. The next thing is going to be to split the reaction into 2. So split it into the half reactions. So you should have one reduction and you should have one oxidation. And you know which one is which because you've done number 1 to determine all the oxidation numbers. All right, number 3 is going to be to balance each. And you're going to do this by adding water. Oops, sorry, that's not the first thing. The first thing is actually to balance elements that are not H or O. The next thing is to add water to balance the oxygens. The next is to add H plus to balance H's. Then we add electrons to balance charges. When we're done with that, then we move on to step 4, where we put the reactions back together. Oops, nope, that's not the next one. The next one is to multiply both half reactions, if necessary, to get electrons equal number in each reaction. In other words, if the reduction equation has 2 electrons and the oxidation has 3 electrons, we want both of them to have the same number, so we would multiply this one by 3, and we would multiply everything in the equation by 3, and we would get this one to have 6 electrons and this one to have 6 electrons. Our goal is to get the same. Step 5 is to add 2 reactions together. Step 6 is to cancel stuff out. And that's it. Okay. When we talk about a basic solution, the basic solution adds one more step. And that step is actually added here. And that step says to C2 is what we'll call it. Add OH to side with H plus to balance out H pluses. Yeah, so it's a weird thing. All right, I will come back to this in a little bit. Okay, continuing with this particular reaction. So we're going to do example 1 first in acidic solution. So we're going to follow all of these steps as we've just outlined them. We've got this dichromate, and chlorine makes chromium 3+ and chlorine gas. And so again, our first thing is going to be to go through and assign oxidation numbers. One that I know already is going to be that chlorine on the right is going to be a 0 charge because it's in its elemental form. We know that chromium on this side is going to be 3+ because it tells us that. We know chlorine on this side is going to be a 1-, so we see that the chlorine is going to change charge. And then we see that this dichromate has oxygen. Remember that each oxygen is -2, and then the chromiums are going to be something we have to calculate. So we know that 2 times X, so X is going to be our chromium charge, plus -2 times 7 for all of the oxygens we have, and then plus a -2 because that's our total charge, or I'm sorry, that the sum of that has to equal -2. And remember, this is like a box method we covered last year, and we've seen it a few times, so just kind of keep in mind. So this is going to be -14 plus 2x equals -2. I'm going to get the charge on the chromium is going to be a +6 on the right side. for just the chromium. Remember, we don't really care about oxygen because we know what it's going to be. All right, I'm going to erase that, keeps ourselves some room. So now we know that the chromium is going to go from a +6 to a +3. In order to become more less positive, it must have gained electrons. And this one, to go from a -1 to a 0, must have lost electrons. Okay, so now we know oxidation is going to be loss, so that's going to be our chlorine, and then reduction is gain, so we know that that's going to be our chromium atom. All right, second step is to split into half reactions. So we need one reduction reaction and we need one oxidation reaction. So our reduction reaction we said was going to be our chromium. Don't worry about the oxygens, that's why we're balancing this. The oxidation reaction is going to be next thing that we're going to do is we're going to balance each one, and we're going to go through this A through D for each of those different steps. So first thing we're going to do with this one, so I'm going to do reduction first and then I'll come back to oxidation. So I'm just going to move this oxidation up here. All right, so let's do this one first. Balance this half reaction. First step says to balance elements that are not H or O. So there's a 2 on this side. We want a 2 on this side. Next thing to do is going to be to add H2O to balance the O's. So in order to do that, I'm going to put 7 H2O on the right side. Doing that means I've also added 7 H2s, so 14 H's, and in order to balance the H's, we have to add the H pluses to balance that. So I'm going to add 14 H plus to this side. Last thing to do is going to be to balance the electrons, add electrons to balance charges. So on the left side of this overall reaction now, 2 minus, with our 14H pluses, 2Cr3 plus 7H2O. All right, so right now, this is our reaction. What we need to do next is to add our electrons. Now, on the left side of this equation, we have a 2 minus and a 14 plus. So 2 minus and 14 is going to be a positive 12 charge on the left. On the right side, we have 2 3 plus charges. So this is just going to be a positive 6 charge. In order to balance these, we're going to add negative charges to one side or the other. And for us, we want to make the left side more negative, so we're going to add our electrons to the left side. So when we write this, we're going to add 6 electrons to the left side and get our overall reaction. Okay. Just give me 1 second. I am going to move this description on the right over. Okay, sorry if it looks choppy. I did my best. All right, so now we have this overall reaction down here. I'm going to go ahead and just rewrite it real quick and add the 6 electrons on the left so it looks a little neater. Oops. And that's our overall reduction reaction. Our next thing to do is going to be to balance the oxidation reaction. And one of the things you may notice in the oxidation reaction is that there is no oxygen to balance. So really what we're going to be doing here is we're going to go through and we're just going to balance the charges. So let's go through the whole thing. So balance elements that are not H or O. So first thing we have to do, oops, is put a 2 in front of the Cl minus. Next thing is to add H2O to balance oxygens. Since there are no oxygens, we're not going to do that. Since we didn't add any oxygens, we're also not going to add H's to balance the reaction. Last thing we are going to do is to add electrons to balance the charges. And so on the left side, we have a total -2. On the right side, we have a 0. We want them to equal, and we can't subtract a -2 charge by adding electrons, but we can add 2 electrons to this side, and that makes this total charge on the right side a -2. All right, so now we have 2 equations. Both have been balanced according to our rules for step 3. For number 4, it's just to multiply the half reactions to get the electrons equal in both reactions. And when we multiply anything in a reaction, we multiply everything in the reaction. So in this reaction, we have 2 electrons. In this reaction, we have 6. In order to get that 2 to be 6, we're going to multiply everything in here times 3. And we're going to get 6 chlorine ions makes 3 and 6 electrons. Okay. Next step is to actually add the 2 reactions together and cancel out stuff that's on both sides. So now we're going to take our 2 half reactions that have been balanced in acid solution, and we're going to add them together. What we're going to get if we do this correctly, our goal is to get a reaction that does not have electrons in it at the end. You'll notice that of all of your reactions that you've seen in this chapter, and in all of the redox reactions you've seen in this chapter, that none of them have straight up electrons if they're put together as a redox reaction, so a reduction and an oxidation together. All right, so next thing to do is going to be to cancel stuff out that's on both sides, and the only thing I see and the only thing you should see is the electrons. So we're going to cancel those, and this will be our overall reaction. All right, that was section 2. I'm going to move on. I'm actually sitting in your Zoom meeting and nobody's here. So keep going. All right, so our next one says to do this in basic solution. And I'll remind you that in basic solution, we're just going to add a step. We're going to call it C2, and we're going to add it here. So this is step C. And after we do that, we're going to actually add OHs. Beyond just adding OHs, we're actually going to add OHs to both sides. So I wrote that kind of wrong. And our goal is to actually balance out the H plus charges. So we'll see how that works out here in a second. All right, so let's start. Our reaction says to complete and balance this equation for a redox reaction that takes place in basic solution. So first thing we're going to do is our first step, which is to figure out what the charges are on things on both sides, so our oxidation numbers. Okay, so over here we have N and we have C. And in assigning the oxidation numbers to N and C, the thing that is more electronegative tends to get the charge it prefers, quote unquote, from the periodic table, which means that N is going to be a 3- charge. And carbon, because that needs to balance out and the whole thing needs to equal a -1, carbon is going to have a +2 charge. All right. With manganate, so here we have an O4. Remember that every oxygen is a -2. There's 4 of them, and the whole charge on the thing has to be a -1. So Mn is going to end up being a +5, 6, 7, 8, nope, +7. A 7. +2 -3 -2. All right, on the right side, we're going to do the same thing. We know that oxygen's always a -2, so we're going to give that a -2 on both of these. We know that this manganate, since there's 2 oxygens, is going to be a +4. We know that since this is a -2 and nitrogen is likely a -3, that carbon has now become a plus, what? -3, -2 is -5. We want the whole thing to be -1. Carbon is going to be a +4. Sorry. And so now we're going to look at things that changed. So nitrogen did not change. Oxygen did not change by definition. So what did change is cyanide, or carbon, sorry, went from a +2 to a +4. In doing that, it lost electrons. Manganate went from a +7 to a +4, so it gained electrons. So that means manganate is going to be our reduction, and carbon is going to be our oxidation. So next thing we want to do is we want to split them into two reactions. So we're going to make a reduction, and we're going to write an oxidation. So our reduction reaction is going to be the manganate. And our oxidation is going to be the Cn minus and the CnO minus. So Cn minus makes CnO minus. All right, next step is going to be to balance them. And so we're going to balance them as if they're in basic solution, which just means we're going to go through the acidic steps, and then we're going to add a step in the balance equation where we add OH minus both sides to balance out the H's that we add from the water. Okay, so for the reduction, first thing to do is to balance the atoms that are not oxygen or hydrogen, and they are already balanced in this equation. Next thing to do is to balance the oxygens by adding water where needed. So on the right side, on the left side, we have 4 oxygens. On the right, we only have 2. So we're going to add 2H2O. Next step is to add H's to balance out the H's. So we're going to add 4H plus. And then this is where the fact that it is a basic solution comes into play. So now what we're going to do is we're going to add OH minus to both sides to balance out the H's. So in other words, I have to add to the left side the same number of OH's that I added H's. So I'm going to do 4 OH minus. And since I added 4 OH minus to this side, I also have to add those 4 OH minuses to this side. What you're effectively doing is canceling out the H and OH's on one side and forming water. But we're not going to write that we formed water quite yet. Okay? So next thing to do is going to be to... next thing is going to be to simplify. So we are going to go ahead and we're going to write in that water. So we're going to get the 4H2O on the left plus MnO4 minus is going to make MnO2 plus 2H2O plus 4OH minus. All right. Next thing we can do is we can simplify this even further by getting rid of the waters that are on both sides. So we're going to get rid of the 2 here, and we're going to leave 2 on the left. Last thing that we have to do before we can go on to the next half reaction to balance is to add the electrons to balance charges. So on the right side, we have 4 minus 1 charges. So on the right side, our total charge is -4. On the left side, our total charge is -1. We want them to equal, so we're going to add 3 electrons here to do that. And then we're done with our balancing of just the reduction. Next thing we're going to do is work on this oxidation, and we're going to do the exact same thing we did over here. We're going to add water, then we're going to add H, then we're going to add OH to both sides, and we're going to simplify the HOH to water, because when you add OH and H, you get water. All right. Okay, so now we're going to do the first thing says to, it says to balance the atoms, right? So atoms that aren't oxygen and hydrogen are already balanced. Next thing we're going to do is we're going to balance the oxygen by adding water. So I'm going to add 1 H2O over here. In doing that, I'm going to add 2 H pluses here as the next step. Then I'm going to add OHs to both sides because we're still balancing in a basic solution. Then I'm going to combine the H and OH to make 2H2O on the right Then I'm going to cancel the H2O on both sides. So this is just going to become a 1, and this is going to go away. Then I'm going to balance with the electrons. So on the left, I have a total of 3 minus charge. On the right, I have a -1. So I want to add 2 electrons to this side to balance the charge. All right. So right now I have an equation that has 3 electrons and an equation that has 2 electrons. Our next step in the process is to multiply by an integer to get the numbers to equal as far as the electrons are concerned. So I'm going to take this and I'm going to multiply by 2. And I'm going to take this and I'm going to multiply by 3. And I'm going to multiply everything in it by 2 and everything in this one by 3. And I'm going to get 6 electrons plus 4 H2Os plus 2 MnO4s makes 2 MnO2 plus 8 OH minus. Did I do that right? Double check. Yep. So there's one of my reactions. And here's my other. 2 times 3 is 6 OH minus plus 3 CN minus makes 3 CN minus 3 H2O 6 electrons. Alright, there's that. To be continued. Okay, after looking at the length of this video, I'm just going to finish this problem, and you're going to do this first one, then I'll film a video that has sections 3, 4, and 5 in it, and it'll be much shorter. Okay, so add these two together. Everything on the left stays on the left. Next thing to do is to cancel stuff out that's on both sides. So we're going to cancel out these electrons. Looks like we've got 3 H2O on this side and 4 on this side. So we're just going to reduce that to 1 on the left. Then I've got 6 OH on this side and 8 on this side. So I'm going to reduce that to a 2. Then I'm going to rewrite this whole thing. Over here. So I'm going to get H2O plus 2 MnO4 plus 3 Cn minus makes 2 MnO2 plus 2 OH minus plus 3 CnO minus. All right, so that is our final answer to this particular problem. All right, for you, I'd like you to do this particular question. Balance this as if it was in a basic solution, just like you saw us do. All right.